It is 2005, the busiest hurricane season on record. On August 27th, a meteorological satellite is tracking a Category 3 hurricane that started in the Bahamas. Its name is Hurricane Katrina. Throughout the region, there is one question on everyone's mind. Will the hurricane hit land, or will it blow itself out? The answer may come from a NASA satellite called TRMM, the Tropical Rainfall Measuring Mission. TRMM is equipped with a radar and imager that operate in the microwave range of the spectrum. These are higher in energy and shorter in wavelength than other radio waves. The instruments bounce microwaves off raindrops in the clouds, allowing scientists to build a three-dimensional model of the internal structure of a hurricane.
We can actually look at microwave energy, which is generated within the clouds and coming from the ocean surface. It's almost as if the clouds are now invisible to us. We can see right through them, like taking a CAT scan to look inside those clouds.
This satellite is a powerful tool. And now, its sensors reveal something ominous. Huge vertical columns of warm water vapor burst up from near the center of the storm. Almost like hurricanes within hurricanes, these climbing vortices deliver added infusions of energy into the heart of the storm, fueling its growth even more. These new sources of energy are called hot towers.
If they occur in the right place at the right time near the very center of the system, they could be like a giant spark plug that gets that whole engine running at very, very high speed.
The hot towers draw more and more water vapor off the ocean. This triggers a feedback loop that leads to a runaway reaction. In just 24 hours, Hurricane Katrina grows into a Category 5 monster. All this violence is a direct result of the power of the sun on the ocean. Ferocious winds blow for 2 days straight, reaching 175 miles an hour, twisting steel like paper and ripping apart homes and buildings. Over 3 trillion gallons of rain a day and a massive tidal surge from the Gulf of Mexico combine to inundate whole areas of the Gulf Coast. Katrina leaves its mark across 90,000 square miles. Over 1 million people are displaced. Katrina becomes the standard by which future hurricanes will be assessed. But even this extreme hurricane is just a tiny brushstroke in a much bigger picture. A picture of how the sun drives water around the entire planet, with radically different effects in different places, all under the watchful gaze of our eyes in space. Take just a single day in July. In New York, commuters swelter in 95-degree heat. Searing winds pump hot air into the region from the south, creating oppressive, humid conditions. 7,000 miles away, in Mumbai, India, commuters here struggle to cope with torrential rain. The deluge comes so fast that the streets are flooded in hours. Meanwhile, in Chile, the desert of the Atacama is almost totally dry. There are places here where rainfall has never been recorded. Such diverse environments thousands of miles apart appear totally unrelated. But by pulling back for a wider view, we can see that they are in fact intimately connected.